The National Council of University Research Administrators, Region 7, Professional Education and Development Committee is pleased to welcome you to today's presentation. The purpose of the PEDC is to support professional development activities for regional members and to provide a broad range of educational services to ensure that all regional members have access to professional development programming. My name is Sarah Martnick. It is my pleasure to serve you today as a PEDC member of Region 7, and I am your facilitator for today's discussion group. This discussion group will be recorded. The presentation is approximately 60 minutes. Please be sure that you are muted during the presentation. If you have a question or comment, please utilize the chat feature or raise your hand. We will be monitoring the chat box throughout the presentation. There will also be a survey link provided at the end of the presentation. Please be sure to complete that. At this point, I'm going to turn this presentation over to Dr. Barrie Robison.
Morning, everybody. I have a few interactive little Kahoot quizzes. And I believe on my screen or that I'm sharing, you can see QR code and perfect. While I introduce myself, I believe my account for this application will allow 50 participants, so it'll be first come, first served, and you get to assign your own fun Halloween nickname, and of course, Katie is first. I'm going to leave that up so that people can kind of see it. I am a faculty member and principal investigator, and I hope that you will not hold that against me for the duration of this discussion. I assure you, I am on your side. I am a professor in the Department of Biological Sciences, but the context for participating here is that I'm the director of our Institute for Interdisciplinary Data Sciences at the University of Idaho. And we have been collaborating with Sarah's group in the Office of Research and Economic Development for, I don't even know how long, about a year, I think.
Yep.
On trying to do practical integrations of generative artificial intelligence into research administration workflows. We have a team in our institute of, I don't know, about 20 different types of very talented nerds, ranging from data scientists to software developers to high-performance computing experts and things like that. And most of what I show you today and we talk about today, I have learned from them and can't do even 1% of it in terms of the coding and things like that. So, holy moly, 129. Are we full yet? No. I'm going to go ahead and assume we're good here and start my slideshow. Okay. The first thing I want to do here is try to get a sense of who's in this Zoom discussion. And so the first question that I'm hoping people can answer on the fancy little phone is, which of the following best describes your role in research administration? This is just for me to kind of get to know what the mix is in the room, and we'll assume that the people who signed up are a proportionate sample of all of the attendees. You got 10 seconds left. We got a lot to cover and not much time, so. All right. Well, that's not at all what I thought I would see. 3 analysts, 12 managers, 2 executives, 1 you don't know me, and a bunch of administrative support folks. And, well, let's be honest, we have 1 recalcitrant principal investigator in the room, and that would probably be me. So I'm going to jump over to this. So we just did that. Here's what I've learned in the years working with Sarah's group. We've enjoyed it a ton. We've come to appreciate how difficult what all of you do is and how important it is, and that all of you are working in this ecosystem and you're doing really, really important things. And I'm not just pandering, I really mean that. And I feel like it's a major bummer because most of the folks that I interact with that are in this space in terms of research administration, although they're a critical part of our national research ecosystem, it's just a giant dumpster fire all the time, is my take on it. So that was my AI version of Sarah. Sarah's headshot is everything burns behind her and she's like, this is fine. And I just feel like everybody is running around all the time with their hair on fire and not really able to sort of sit back and think about, how fulfilling it should be to be working in this area. What a shame. Okay, here's my assessment of why that might be. Modern research administration. This is all of you. I would argue that over time, let's just say over the course of your career or the last 20 years, whatever you want to look at on the right, we have time on the x-axis. I believe it is true that you have seen some version of increased work volume. More proposals, more grants, do all the things, right? I assume you're nodding. I can't see anyone because of the way I've got PowerPoint set up, but that's fine. I also will assert with only some evidence that the task complexity over time has increased dramatically. I will also assert with only some evidence that your risk portfolio has increased dramatically and the stakes are much higher and the cost of mistakes in terms of compliance and legal liability and things is going up and up and up. So ideally, you would be able to account for all of this because you have been resourced commensurate with these curves in terms of the demands on your time. And I know you're all laughing because the reality is, at best, you're probably operating in a stagnant resource environment over time. And if you adjust for inflation and all of those kinds of things, you've probably declined in terms of your resource capacity. And the problem is when those red, purple, and blue lines are above the resource line, you have a substantial capacity deficit. And that leads to that image of Sarah, standing in front of a giant AI-generated fire. It leads to really, really low job satisfaction. It really leads to mistakes. It leads to offices that are chronically behind. And honestly, it leads to a degradation in the capacity of our research enterprise at the national level. This is not a good thing. Now, you have two choices. And for those of you that are executives, when you are in this situation, one, you can spend your way out of it. I'll give you a minute to laugh at that. Or two, if you want to keep up, you have to look for efficiencies. There's not a lot of other options in terms of how to do this. Now, you can get efficiencies. So this is why modern research, electronic research administration software exists. So all of those companies that I hear about, like Huron and Cayuse and them, they exist because they provide a certain amount of efficiency at scale for the processes that are important to you. And all of us living in this gap era of not enough resources and too much complex and important work to do, those systems are great if you can afford them. But we all have this intuitive sense that these new generative artificial intelligence tools could really make a difference here. So, well, I think all of us believe that is true. We also, I think, recognize that there's a lot of hype and a lot less felt impact, right? Like, it can do some stuff, and to varying extents, your universities have provided access to it for you and implemented some things, and maybe it's made some differences and stuff. But I would argue that most of us have passed the peak of inflated expectations in the Gartner hype cycle, which is a business thing, and we're falling rapidly into the trough of disillusionment. I feel pretty strongly that this hype cycle is very, very similar to the notion of the Dunning-Kruger effect, whereas on the x-axis in the bottom left, as the amount of knowledge increases, uh, uh, when you're a complete noob at something, you're very confident. Oh yeah, I got this, and you get to this point of that we call the peak of Mount Stupid. But then, as you accumulate more knowledge and experience, you realize, wait, this is a lot more complicated and a lot more difficult than I thought. And you fall off the peak of Mount Stupid and enter the valley of despair. And eventually, you gain enough expertise that you are becoming productive. I think that these things are related to what we call the innovation valley of death. We all know that modern data science can transform research administration, and yet the penetration of those kinds of tools into research offices for smaller schools or even mid-sized schools is very slow. And that's because it takes a lot of work to actually have those things generate a felt impact. Artificial intelligence is the same. Now, Sarah, like I can't see the chat or anything like that, and so I assume you're just going to jump in and interrupt me if there's important things going on or questions or whatever. So
Yes, I will. So far, you've gotten, I feel very seen, and many comments about how scary AI Sarah was.
well, you should meet real Sarah.
She's terrifying.
That, all right, yeah, anyway, happy Halloween. All right, let's move on to from the theoretical stuff. Okay, so what we end up with is this. This is some cartoon of what we call the diffusion of innovation model. And whenever some new thing comes along, you end up being able to categorize people into, or even businesses, or say research offices, or whatever you like, universities, into these general bins. The innovators, which are the ones like creating and modifying and putting the technology to work. The early adopters, the early majority, the late majority, and the laggards or the Luddites or the whatever you want to call them. All of you are probably, in terms of thinking about generative AI and your research administration workflows, I think that you can kind of intuitively put yourself into one of these categories. So let's do another quick poll here. Now, I'd like to know, for the 50 of you that were able to jump in, can you rank yourself in terms of your experience and knowledge related to generative AI? Particularly, like we really want to focus on research administration, your workflows. Let's close that gap between resources and demand on what you're trying to do. So 39 answers submitted. All right, that's great. Okay. The good news is no one thinks they're Skynet, which is, that's a good thing. And we have some folks who are, in the area of probably early adopters. Don't think anyone on this call would be an innovator where you're training your own models, but you never know. Maybe Sam Altman's here. Who cares? Right. But I think like most of us are still in this area of like, how do I get past the hype cycle and the peak of Mount Stupid and into this notion of the plateau of productivity? I need to put this to work and have it make a difference. And that's what I'm kind of hoping I can at least stimulate a discussion about today. I don't have all the answers. We have our approach that I want to share a little bit with you, maybe some insights. We can have a little chat. I can answer some questions. You can yell at me. I don't know. Anyway, my goal is to hopefully help people deploy generative artificial intelligence as force multiplier for research administration without destroying your career. Force multiplier comes from like the military and stuff. So, anything that improves the efficiency or effectiveness of a fighting force. So a tank, machine gun. Skill saw is a force multiplier for a carpenter, and Excel is a force multiplier for most of our like office work. Get it? Okay. AI is no different. Lets you do more with less, which is what all of your bosses want. Right? It's important before we dive into this stuff to think about how this lines up with your actual workflows and tasks. So we know why you do what you do. You exist to help the nation get its research done. We don't get generative AI, frankly, unless all of you were already doing your jobs. That emerges from the nation's research enterprise, and that research enterprise depends on effective administration. That is why you do what you do. So what you do, I don't know. We've done a lot of little things where we watch Sarah's team do their stuff, and then we cry a lot. We go away and we're like, wow, how do they even, because it's tragic. There's a lot of document processing, what you're doing, data stewardship, even if you don't call it that. You're trying to find data, and I got to copy it, and I got to put it over here and put it over there, but I also got to store it in my magic spreadsheet. And if I get hit by a bus, boy, is the university screwed, because all that important data is only on that magic spreadsheet. You're organizing it, and you're answering questions from us recalcitrant PIs, and you're doing a million other things. But the real key is to start to understand, okay, how am I doing it? How am I doing it? And how can I align what generative AI is good at to maybe offload some of that cognitive labor so that I can spend that precious mind power on things that are more important and less menial and tedious. Okay. Blah, blah, blah. Here's how these models work. I'm gonna try to keep this as non-technical as I can, because the technicalities kind of don't matter. You're going to hear a lot about model training with generative artificial intelligence, and none of us on this chat are likely to ever do model training. That is what OpenAI, Microsoft, Google, Anthropic, Meta, that all of those companies are boiling our oceans with their insane power demands, training the models on every scrap of text data you have ever generated and humanity has ever generated. Okay, so those models are getting trained. What we're doing is inference. We're taking a trained model, which is it doesn't even matter. Like, it's a big network of matrices and weights, but who cares, right? The metaphor I like to use, well, I'm going to skip the sorting hat metaphor, but we're doing inference. We're asking the model to do inference. We're saying, hey, here's some stuff, and we send it to the model, and we get an output that is valuable to us. So how that is done, the reality is we're going to stick with text for this little discussion, but these models are becoming more and more multimodal, and you can use text, images, voice, songs, video, audio, protein data, all of these kinds of things. The reality is what we put in gets encoded, essentially turned into numbers. It gets passed into one of these models, and then that output is a different set of numbers, and that is decoded into, in our case, it's going to be text, and that ideally has value to us in terms of our workflows. So let's eliminate all that multimodal junk, because we're not trying to make new pop songs or more Sarah's on fire videos. Most of what we are all dealing with is likely the text ones. So these would be called large language models. It's important to understand that, what we put in, let's call it a prompt. Chances are all of you know that. And what we want out is the response. Again, all of you know that. You're going to hear this term called context window. That's just the amount of text. And you're going to hear this term called tokens. Most of us, we generally think of one word as one token. Not technically true, good enough for our purposes. Amount of words in your prompt and amount of words in your response, that can't exceed what we call the context window. And the different models have different context windows, and the bigger the context window, the more expensive the model. But this matters because some of your tasks are highly complex, and they involve a ton of documents, and exceeding the context window, and like what you're asking it to do, the amount of information and what is in your prompt versus what is in the model itself versus what you expect in the response, these things matter. You are making choices when you do that kind of stuff, and you really need to understand the consequences and trade-offs of those choices. And so that's one of the things I'm hoping to focus on today. Okay, so here's the first kind of take-home lesson before we get into some more fun examples. There's two pieces to this whole situation that we're really excited about, and we sense it can deliver a lot of value to us in terms of the generative AI models. Trying to keep it on 20 minutes. I got to go fast and stop talking. Okay. One is semantic coherence. Does the output make sense logically? Is it consistent with the topic? Is it appropriate for the context, conceptually aligned? And one is factual accuracy. Is the information correct? Citing sources, performing math, counting things. These LLMs are trained to give you semantic coherence, and we are often asking them for factual accuracy. And the reality is, factual accuracy is a serendipitous and desirable byproduct of what these models are trained to do. So that would be a thing you really, really, really need to consider. And if you're wanting factual accuracy, you need to really be careful about how you engage with the model to maximize the probability that you get both semantic coherence and something that is true. Here's the last quiz, and then holy moly, time goes fast. Here's an example. You are all now going to be our very own large language model, and you are going to complete this prompt. Our prompt is, the robots are going to eat blank, and all of our participants are our large language model, and we're going to see what is produced. Then good. Here's the word cloud. Knowledge, information, candy, data and energy, apples, smashing pumpkins, love it, bear, my homework, data, pizza, crossed it out, electricity, bites, metal, cheese. How many of these answers are semantically coherent? The answer is all of them. How many of them are factually accurate? The answer is the model doesn't give a crap, right? And yes, they are the factually accurate answer is research administrators, of course, but this is what these large language models do, and they do produce different results if you prompt them the same way every time, right? I hope they don't eat cats. That's bad. So that example is something that we want to keep in mind when we're trying to navigate this world and put these things to work without destroying our careers. If you put these things on an axis, complete fabrication on the left, absolute truth on the right, utter gibberish on the bottom, semantically coherent on the top, and you look at these different quadrants over here, convincing liar, bad. Down here, modern political discourse. It neither makes sense or has any truth to it anymore, right? Over here, a high quality textbook. And then when I give this talk to my faculty colleagues, right? The first draft you get from your graduate student for that manuscript, it's got some truth in it, but it's mostly utter gibberish. So when you're thinking about your use cases, you want to be considering, how do I evaluate this use case and mitigate the pain because it's a long fall from the peak of Mount Stupid. You want to think about the frequency of the task, the complexity of the task, the risk of getting a wrong answer, how much semantic coherence is responsible versus valuable versus factual accuracy. And if you want this to scale throughout your organization, you have to think about replicability of the method, reproducibility of the result, validation and trustworthiness of the result. And if you're limited to chat interfaces, those things are hard to do. And then ultimately security. You don't want to be sending valuable IP over the internet to Sam Altman and OpenAI. Now, some of you have enterprise, blah, blah, blah. Okay, I'm going to skip over this because I'm already out of time. Holy moly. I like to think of large language model tasks or operations in three categories. And likely in terms of time, we're going to talk about just the first one. Reductive, small amount of input, or a large amount of input turns into a small amount of output. Transformative, we're reformatting or refactoring, but the input and output are pretty much the same size. And generative, which is mostly what people tend to think about these things with and use them for. Small prompt, large result. Examples of some reductive operations that you probably would find valuable in your workflows are summarization, distillation, extraction, characterization, analysis, evaluation, critiquing. We're going to focus on a couple of very specific examples. And the reason I want to start with reductive tasks is your workflows are filled with these. They often are the same reductive task occurs very frequently. They are often quite menial, and you really don't want to be spending your valuable brain power doing them. They're repetitive, they're tedious, and they can be much easier to validate because it's easier to know whether the answer was correct when we're testing them. And we can scale them beyond just say, telling everybody, just use Copilot to do that, right? So let's have a look. Sarah can throw this in the chat, I guess. So we have an NSF grant through the granted program where we're working on some of this stuff I'm about to show you, and we'll have our discussion. And kind of this is sort of defined by our approach to like how we think about these things, beyond just saying, oh, if you just give everybody in the research office access to ChatGPT or Copilot or whatever your university is working out, that's fine, and it can deliver value for sure. But we're trying to sort of share our perspective on other ways of thinking about this. So here's the example I want to use. This is what we call a vandalizer that we're building for this kind of thing. That's good news, I assume, right? I know an award letter shows up. Now, I assume this is highly variable across institutions, and big and rich institutions that can pay companies a lot of money. Maybe they don't have the problems I'm about to describe, but we sure do, and I know lots of other smaller universities do as well. Here's an award letter. Ironically, the federal government uses its preferred method of transmitting important data is officially email, which is stupid. And often it's contained in PDFs, which these things were not ever designed or intended to be the vehicles of data stewardship, but here we are. I'm going to argue there's a ton of very important information in this award letter PDF that somebody in your office has to figure out, okay, well, whose proposal is this attached to? Where does this information get stored? What do I have to take out of here and put into our research administration system? Who needs to know about this? Is there weird stuff in here I have to worry about in terms of, that kind of thing? When this hits the inbox and somebody opens this email, what I would love is if everybody could throw in chat, how long does it take to go from here is this email to getting all the data out, putting it in the correct spot in your various systems, storing this and affiliating it with the right proposal and that kind of thing. I'd like everybody to throw their estimate in chat in terms of how long does that process take? I don't know, 2 minutes.
Barrie, are you wanting just receipt to tying it to your ERA system record, or are you wanting receipt all the way through accounting setup?
Oh, no, not accounting setup. I just want when you're done with the award letter, you've got all the information out of it and it's been put in the right places and the right people know about it and that kind of thing. It should be I would assume in minutes, right? So, yeah.
In 30 minutes, 10 minutes, a few days, 2 to 4 hours.
A few days. Oh, no. Okay. Anyway, let's go with 30 minutes, right? Okay. Okay, here we go. You ready? Extract. Those are all the target pieces of data we want out of here, right? Hope somebody's got their stopwatch going. This is a reductive prompt operation for a highly frequent task, an NIH award letter, right? There's a bunch. Oh, look, we're done. Didn't take a few days. Right. This is efficiency. This is what we all sense is possible. The good news is with tasks like this, it's also easy for us to test and evaluate whether these things are correct, and scale it. So the way we've set the vandalizer up, for example, is if okay, if this is an important piece and as an analyst, we're trying to build trust. Does it work? You're right to be cautious. You can click here. It shows you where in the document it pulled it, right? So we can start validating. When you're confident you're good, you just hit export, you get a CSV file, we could connect it to an SQL thing to insert it into whatever database you like, all of that kind of stuff. Right? So we're good. Awesome. Except that not all PDFs are created equal. So what do I mean by that? Let me just show you, and then maybe I'll pause and take some questions. Let's
There's a
try.
question, Barry. How is the
Yeah,
extraction used?
that's a great question. So I can answer that from our perspective. If we want to set up this fancy new NIH award, we need to know how much money are they giving us? What's the actual start and end date? What is the method of invoicing? Obviously, with NIH and NSF, it's a little more straightforward than the, kind of one-off commodity commission contracts and stuff like that. But all of those pieces of data need to go into your financial system or your electronic research administration system or your special magic spreadsheet, so that you can track things like budgets and set the award up and that kind of thing. I don't know. I hopefully answered that question. Here's a NIFA award. All right. If I try to extract this, I can tell you right now, NIFA does a lot of great work, but they're really not great at setting up PDFs. For example, look at this. The period of performance is this through this. The start date is this. And I can assure you, the FAIN, not found, okay? If I do this 4 times, I will get different results. And then Sarah and Sylvia were playing around with this with the BLM award letter. You get different results and all of this kind of stuff. And it turns out that not all PDFs are created equal. And we finally figured out that I didn't know the term decompression bomb was a thing, but anyway, BLM is apparently putting these in their PDFs and stuff like that. So if you are just imagining, okay, you have a bunch of analysts and they have access to ChatGPT and you're telling them just extract the data out of these award letters with ChatGPT. Well, sometimes it won't work. Sometimes you would get inconsistent results, and it's a function of these agencies making their PDFs that don't make any sense. Now, the good news is we've got systems that we've set up that fix that, but it's a challenge, and the validation part is on you. This can't scale organizationally until you understand what's going on. Where does this work? Where does it fail? Why does it fail? Can we fix it? We don't want one analyst not being aware that BLM award letters don't behave, and they're happily extracting data and making tons of mistakes. So I'd love to hear questions or pushback or concerns or comments or something like that.
I have a question just in terms of setting up that extraction piece. I would assume there was some fine tuning, human inputs needed to get it to cleanly and succinctly prepare all of that information. I was just wondering kind of how long that took and if there were any common hangups or problems with getting it how you want it.
For the extraction piece?
Yes.
Yeah. So what we did a lot of testing with a bunch of NSF award letters, for example, and NIH award letters where we knew the right answer using Sarah's data. Like we took old stuff where they had manually extracted everything and set it up, and we took those data and we said, here's the right answer. Here are these award letters. Under the hood, we did some prompt engineering. We did some different model testing. We didn't do any fine tuning. That's rarely necessary for this kind of stuff. But we did evaluate it, and I can tell you there were some PDFs where it just kept getting it wrong. And we were like, why? And then we realized it wasn't. Sarah's team got it wrong. And what we were finding was manual data entry errors that had been living in our system for a year or more. But our philosophy is we should be convincing all of you, research administration professionals, that this works. We should be able to tell you the percentage of time each extraction field is successful on this task and which models we tested and that kind of stuff. And so that's what we're working towards. No fine tuning, none of that. Some prompt engineering to get the extraction to work properly. And then there's some coding on the back end for formatting and stuff.
Barry, can I add just a little bit to that?
Mm-hmm.
Just to add to that, so Barry said he took my team's data. When we move an award setup into our financial system, we're a banner school, we fill out a form, essentially, we call it the export form. All of the data goes in there, and then we use an API to push that data into our financial system. And so what Barry is saying is he took a repository of award letters that existed that already had account setups. He then took all of those export forms and compared what our vandalizer extraction pulled out versus what we had put in our export forms. And that's where he found the manual human errors where the model was getting the answers right, but my team had gotten the answers wrong when they created that export form. So that was the way that we built trust in that initial stage. We've got Garrett and then Alexa.
Yeah, okay.
Thank
So
you.
you're, because there's some questions in the chat too that I'd love to answer. So.
Okay.
So Barry, one of the things that I'm concerned about is that we're going to have a situation like we have right now, where we have multiple companies offering products and solutions to us, and they're, vertical silos that that don't talk to each other. Do you see any hope for the future in this software solution where we'll have like a shared product that we could integrate, where all of us testing is better than some of us testing?
That is my fondest hope. Even here, I see some questions about open source and all of this kind of stuff. We are trying to get our folks, our bosses, to allow us to develop this under a Creative Commons open source license, non-commercial. Because what I think would be ideal is if we have this community and we say, here, we've developed a giant data set of validated questions for award extraction. And so when a company comes in and says, yes, we can do this, they can say, yeah, we've taken that data set that you all produced and we've run our thing. Here's our evidence that it works, right? I think about your example that I saw at the Incura meeting in terms of the uniform guidance, right? What if we actually came up with either a fine-tuning or a benchmarking data set of use cases in the uniform guidance where there was a high quality determination made and all of this kind of stuff, so that whenever somebody said, hey, there's a new model out, let's test it against this data set so that we know what's it good at and what's it not for evaluating situations against those rules, so that I would love that. I do have hope, but yeah, it is sort of weird and siloed right now.
Let's have Alexa next,
Yeah.
please.
Thanks, Sarah. So I have a question about the API, and I assume, well, the API is connecting into your Cayuse program. Did you have any pushback from Cayuse and allowing the API to put data into Cayuse? So we have InfoEd, and we get pushback from InfoEd about using an API to put information into InfoEd.
Yeah. So we're not actually pushing info back in just yet. Ideally, we would do that into Banner, into our financial system. And I don't know, maybe we have colleagues from some of these companies on the call or something like that, but I worry about what I call enterprise data hostage taking. They don't like that, they have valuable intellectual property in terms of their data models, and they don't like it when you want to extract custom things out and when you want to put custom things in. And that, I think, gets to Garrett's comment as well about, so that is what we aspire to do, is just have this be an SQL insert call, right? But that is a challenge when you have enterprise systems.
There is a question in the chat, Barry, that's similar. Are you taking the extraction and using a tool to automate it into your system?
No, I would say that's much more conventional data science. So a lot of what large language models allow us to do now is like offload some of this cognitive labor related to like finding that information, and we're going from unstructured data to structured data. But once the data are structured, you don't need AI to put them into your database. We know how to do that, and so we don't. That's not necessary. That's why SQL exists. So.
And can I just expand on that? So that is more my question. So you get this data extracted, and then are you mapping it to, it sounds like you're not mapping it to Banner yet. Because that would be this real big save of manual entry, right? It's to take this validated data and upload it and generate the award and we use PeopleSoft, which PeopleSoft does allow you to upload. But just curious, it sounds like it's on the horizon, but you haven't done it yet. Is that correct?
That is correct. And that's because there's a couple of reasons for that. And one is getting right access to Banner is a tightly held and moderated ability, and so we have to work with OIT or IT folks to do that. And we want, we want to. I'm showing you guys this stuff, but there's so much more testing and things to do. We're just in a phase now where we're trying to set up meetings to get Sarah's team to use this tool and give us a bunch of feedback so that we can find bugs and all of that kind of stuff. So we're just not quite there. We could do that in a day if we had the authority, but we're just like, we want to make sure it's right. So.
Barry, there's another question. What LLM model are you using behind the Vandalizer?
We can point it wherever you or we want. So we have tested, we've tested GPT 3.5, 4, 4.0, Llama, whatever. For these kinds of extraction tasks, our philosophy is point the task at the fastest and cheapest model that still gives you the right level of accuracy. Generally, for these kinds of extraction tasks where the PDF is properly structured, like an NIH, 3.5 can do it fine. We have on-premises inference servers running local open source models. If you care about security, you kind of want to do that. You don't want it to go out off campus and stuff. So right now we just tend to use an OpenAI endpoint and point it to GPT 4.0 or something like that, but when the PDFs don't behave, like a BLM or NIFA and stuff like that, we start to use some combination of vision-enabled models, and that tends to solve those kinds of problems. So
there are no other unanswered questions in the chat, so if you want to raise hand or unmute, you're welcome to.
Yeah, I mean, I can. I got more stuff, so I can prompt another round of discussions by showing you another example or something like that. So if there are no questions or things.
But you did get a note. We would love to see another example.
Okay. Let's talk about transformation operations. So again, what you want to really think about, okay, what are the tasks in my workflow? And what are the pieces where I can, automate or offload cognitive labor, make things go faster, get higher quality results, have our people spending more time doing the stuff that we really want the humans doing. Transformation operations are, I don't know, they're sort of an in-between thing. There's definitely examples. in the research administration world where these are valuable, you know, I'm not going to talk about all, you know, yeah, sure. Have it reformat your email so it's better or something. Yeah, we all know that kind of stuff. Obviously there's translations. The example I'll show you here is sort of related to like, here's one of our faculty members. She has a sub-project in one of our new COBREs related to women's health and stuff like that. Here's the abstract. You'll note there's no public health relevance statement or something like that. So an example of a transformative prompt is like, take this densely technical information and, you know, transform it into something that the lay public can understand. There's lots of stuff that we do in research administration where this might be quite useful. And these models are really quite good at that. And really, this is about semantic coherence and not really factual accuracy. And so this is, I would argue, they almost always produce something that is not quite as good as the PI would write themselves, but is better than any other human on the planet would write, knowing what they know about that PI's research. And it's like, that's good enough for me. You know, these things, in my mind, you don't often need them to scale beyond individual chat window access. So I feel like everybody sort of has an intuitive sense of what they're good at. Here's the place where everybody wants the value to be and where we often get into a little bit of risk. Generative operations, small prompt, big output. Write my introduction for my Nature paper. And remember, they're trained to do semantic coherence, and sometimes we want them to do factual accuracy, and you sometimes won't get it. The example I used in a previous talk was, so a generative prompt is like, I took this abstract for this research, and there's this little bit in here on her hypothesis, and it's the approach. You're going to test our hypotheses with this prospective double-blind study, blah, 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 blah. An example of a generative prompt here is write the code, the R code, that would analyze this data. Does it in 4 seconds, and it works. Here's the thing. I can evaluate this because if the code doesn't work, I get error messages. If I do this part and I say, write an introduction for this work suitable for Nature and add citations, it gives me something that's semantically coherent, but this is where we get into the realm of hallucinations. It gave me a whole bunch of citations for this, all of which were made up. And we've all heard those stories. And so when we sort of get into these, the notion of using these things in a generative way, it's possible. You can do it, and it can work. But keep in mind, it's harder to evaluate whether it was correct because it's sort of, it's like it's subjective, you know, it's so the evaluation threshold rises. It's, you know, and a lot of times these are these situations where the risk is higher. And so you really want to make sure you sort of understand what you're asking it to do. So if you're just saying, write an email to my staff, reminding them of these things and, you know, whatever, that's awesome. Do that all day long. You know, I keep coming back to Garrett and Alexa when we were talking about the uniform guidance stuff and evaluating these things. So important and so valuable and that kind of thing. And yet I just feel like we need some research on this. You know, we need to understand like where are the gaps and, you know, how often does it get it right? I can show, I don't know, I'm happy to answer any more questions because I know we're like 6 minutes left. I've got one other thing I could show, but. So the notion of transformative and generative, really quick. All of you probably get these questions from some person who wears a suit for a living. hey, there's this crazy new cool grant opportunity or this collaborator from industry or whatever. Who do we have on campus that does research in blah? Right? And that's often hard to navigate, and you're trying to crawl through, campus websites and do keyword searches and stuff. So remember, these tools are really good at transformation, summarization, and that kind of thing. And so we've set this thing up where we took everybody's titles and abstracts from the University of Idaho and used them to generate summaries of what our researchers do. And this is what we call a semantic search, which means I can look for infectious disease.
It appears that Zoom has kicked Barrie out. So that's good. If he's able to get back in, we have a couple minutes left and he can show you the semantic tool. What he was going to show you is essentially a repository tool where
I think
we
I'm back.
can, yep,
I'm not,
there you are.
yeah. I don't know. Like my computer is doing a really weird thing, so I think we better call it in terms of what I'm going to share, because I feel like I'm about to crash.
Okay. Well, thank you everyone for attending today's webinar. It will be made available on the NCAR Region 7 website under the Education tab. We thank you for your participation today. Please be sure to complete the survey.
Thanks, everybody.